Let's dive into our structured or relational database services. First up is Cloud SQL. Why would you use a Google Cloud service for SQL when you could just install a SQL Server application image on a VM using Compute Engine? The question really is, should you build your own database solution or use a managed service? There are benefits to using a managed service, so let's learn about why you would choose Cloud SQL as a managed service inside Google Cloud. Cloud SQL is a fully managed service of either MySQL, PostgreSQL, or Microsoft SQL Server databases. This means that patches and updates are automatically applied, but you still have to administer MySQL users with the native authentication tools that come with these databases. Cloud SQL supports many clients, such as Cloud Shell, Application Engine, and Google Workspace scripts. It also supports other applications and tools that you might be used to, like SQL Workbench, Toad, and other external applications using standard MySQL drivers. Cloud SQL delivers high performance and scalability with up to 30 terabytes of storage capacity, 40,000 IOPS, and 416 gigabytes of RAM per instance. You can easily scale up to 64 processor cores and scale out with read replicas. Currently, you can use Cloud SQL with either MySQL 5.6, 5.7, or 8, PostgreSQL with 9.6, 10, 11, or 12, or either of the Web, Express, Standard, or Enterprise SQL Server 2017 editions as of this recording. Let's focus on some of the other services provided by Cloud SQL. In HA configuration within a regional instance, the configuration is made up of a primary instance and a standby instance. Through synchronous replication to each zone's persistent disk, all writes made to the primary instance are replicated to disks in both zones before the transaction is reported as committed. In the event of an instance or zone failure, the persistent disk is attached to the standby instance and it becomes a new primary instance. Users are then rerouted to a new primary. This process is called failover. Cloud SQL also provides automated and on-demand backups with point-in-time recovery. You can import and export databases using MySQL dump or import and export CSV files. Cloud SQL can also scale up, which does require a machine restart, or scale out using read replicas. That being said, if you're concerned about the horizontal scalability, you'll want to consider Cloud Spanner, which we'll cover later in this module. Choosing a connection type to your Cloud SQL instance will influence how secure, performant, and automated it will be. If you are connecting an application that is hosted within the same Google Cloud project as your Cloud SQL instance, and it is co-located in the same region, choosing the private IP connection will provide you with the most performant and secure connection using private connectivity. In other words, traffic is never exposed to the public internet. Note that connecting the Cloud SQL private IP address from VMs in the same region is only a performance-based recommendation and not a requirement. If the application is hosted in another region or project, or if you're trying to connect to your Cloud SQL instance from outside of Google Cloud, you have three options. In this case, I recommend using the Cloud SQL proxy, which handles authentication, encryption, and key rotation for you. If you need manual control over the SSL connection, you can generate and periodically rotate the certificates yourself. Otherwise, you can use an unencrypted connection by authorizing a specific IP address to connect to your SQL server over its external IP address. You'll explore these options in an upcoming lab, but if you want to learn more about private IP, see the link section of this video. To surmise, let's explore this decision tree to help you find the right data storage service with full relational capability. If you need more than 30 terabytes of storage space, or over 4,000 concurrent connections to your database, or if you want your application design to be responsible for scaling, availability, and location management when scaling up globally, consider using Cloud Spanner, which we'll cover later in this module. If you have no concerns with these constraints, ask yourself whether you have specific OS requirements, custom database configuration requirements, or special backup requirements. If you do, consider hosting your own database on a VM using Compute Engine. Otherwise, I strongly recommend using Cloud SQL as a fully managed service for your relational databases. convinced that using Cloud SQL as a managed service is better than using or re-implementing your existing MySQL solution, see the link section for a solution on how to migrate from MySQL to Cloud SQL.